This is the first lesson for our conic sections in Chapter 9, and it will be about parabolas. We've actually talked about parabolas before, and you'll recognize a whole lot of the information that goes with it, but today we're going to focus on the parabola itself rather than the fact that it's also a quadratic function. If you want a copy of these notes that I'm using, you can get it. It should be there should be a link either right above or right below this video. Okay, a parabola is the set of all points in a plane that are equidistant from a fixed line called the directrix and a fixed point not on the line called the focus. This down here is the directrix. This right here is the focus. So if you do the distance from the focus to the vertex and the vertex to the directrix, it's going to be the same distance, and we're going to call that distance C. And you're going to see that right here in this formula. That's going to help us graph these parabolas. All the parabolas we're going to deal with are going to have a vertex at the origin, so the H and the K will always be 0, 0. So we're going to use a modified formula. So we're basically going to use this formula here, and then we'll use another formula also with a different type of parabola. The first parabolas you're going to look at will be the ones that either open up or down, and this is what we've dealt with before, that the parabola that opens up, the parabola that opens down, we've dealt with it. That's the stuff we're kind of used to. That always has an x squared in its formula. If the 4cy is positive, the parabola opens up. If the 4cy is negative, 4cy is right here, by the way. If the 4cy is negative, then it opens down. Okay? We've dealt with that before. Positive opens up, negative opens down. All right. Going to the next type of parabola. These parabolas either open left or right, but it's going to have a very, very, very similar formula. The only difference is in this formula, it's y squared. So left or right parabolas are always going to have a y squared, and it will either open to the right or it will open to the left. And if the 4cx is positive, it will open to the right, and if the 4cx is negative, it will open to the left. Okay? But again, you can see this has a focus and it has a directrix. The directrix is not going to be seen on the graph. It's not part of the parabola. It just it helps measure the distance that creates this U-like shape. But we are going to be using this C value because it's the same C value that's in my formula. Alright, that's just basic information about the two types of parabolas we're going to see. And now I'm going to show you how we're going to use this information to work this all out. And we may go back and look at those notes a little bit here in a moment. The first example that I have is x squared. And if x is squared, that means it either is going to open up or it's going to open down. And you can see 8y is positive, or at least the 8 itself is positive, so this is going to open up. Okay, and I'm going to switch to something easier to write with. Alright, so to be able to graph this, I've told you that they're all going to be centered at the origin. So I'm going to make a great big huge dot in the middle there so you can remember always these vertex for all of these are going to be at the origin. As a matter of fact, I don't know what's going to happen in the next example, but I do know it's going to be 0, 0 no matter what. So I'm going to use this 8y, and I'm going to write right in here. 8y is equal to 4cy. Let me go back and show you why that's true. When we have x squared, it's equal to 4cy. Now I'm going to go back forward to that same example. X squared, so it's equal to 4cy, but in our case the 4cy is 8y. And we can actually just drop the y off. So we have 8 equals 4c. So if you divide by 4, then your c is just 2. So c is 2. Okay? I'm going to erase this because I need the space. Okay, so my vertex is 0, 0. We know it opens up. My C is 2, so I'm going to go to 2 dots up, 2 units up on my graph, and that actually tells me where my focus is, which is at 0, 2, because this point right here is 0, 2. The other thing that the C does for us is it tells us how far to go in each direction. So let me back up and show you that part too. When we're at the focus, you go 2C this way, and you go 2C this way, and it creates 2 points. So going back to our picture, C is 2, so if I go 2C, that's going to be 4. So from my focus, I'm going to go 4 units to the right and to the left. So let me erase a little bit because I've made kind of a mess here. Oops. Let me start this again. Okay, so I've got my vertex. I've got my focus up here at 2. And from the focus, I'm going to go 4 units to the right and 4 units to the left. And then connecting these points to my vertex, voila, I have a parabola. Now notice if you go 4 units this way and you go 4 units this way, then total distance across here is 8, which interestingly enough is also in our problem. Okay? So we've graphed it. Now where will the directrix be? The directrix is always opposite the focus. So if my focus is here, pardon me, then I'm going to go 2 units the opposite direction to draw my directrix line, which would be right here. So the directrix equation would be y equals, try that again, y equals -2. Okay, so this first example is very sloppy, and so it's just to kind of give you an idea. So let's try another example so I can make it a little bit more clear what's going on. All right, so for example 2, we have 8x equals y squared. And if 8x equals y squared, then 8x equals 4cx. So I'm going to go back to that page to show you where I'm talking about y squared equals 4cx. So y squared equals 8x, so y squared equals 4cx, and the x's, of course, just drop away. Divide both sides by 4, and lo and behold, we are back to having a c that is 2. Alright, so I skipped 2 very important things. First of all, which way does it open? Well, it's y squared. Y squared either opens to the right or to the left, and since 8 is positive, this is going to open to the right. To the right. My program's not working too good with me right here. Alright, it opens to the right. You guys are just going to have to trust me. And the vertex, of course, is at 0, 0. And C, let me put an R there. How's that? It opens to the right. Okay, so C is 2. So I'm going to go ahead and plot these points. The vertex is at 0, 0. It opens to the right, so I'm going to go right 2 places because C is 2. And that's my focus. And from my focus, I'm going to go twice as far in each direction. So since I went 2 units from 0, 0 to 2, 0, 2, 0 being my focus now, from 2, 0, I'm going to go 4 units up. 1, 2, 3, 4. 1, 2, 3, 4. Try that again. 4. And then when I connect those dots, I have a perfect little parabola there. If the vertex is at 0, 0 and the focus is here at 2, 0, then my directrix is going to be over here at -2. So the focus is at 2, 0, and my directrix now is x equals -2. Notice that when my equation says y squared, up here, there we go, that's better, then it matches over here, then my directrix is vertical right here, and so its equation is going to be x equals. Alright, let's try another example. Actually, let's try this third example down here. Okay, for example 3, which direction is this going to open? It's y squared, which means right or left, and it's -4, so negative means it's going to open to the left. So I'm just going to put an L. -4 x is going to equal 4cx, and cancel your x's out and divide by 4 on both sides, and you're going to get c is -1. So c this time is -1. Vertex is still 0, 0, and it will always be 0, 0. Okay, so let's erase some space. Erase some stuff up here too, so it's not so. Alright, now my vertex is at 0, 0. And my parabola opens to the left, so I'm going to go left 1, because c is -1. And then if c is -2, I'll try that again. If c is -1, then 2c is going to be 2 times -1, which is -2. Now, really, we're not that worried about the negative, because we just need to know that we're going to go 2 units up right here, and 2 units down right here, and then I'm going to connect those points to have my parabola. So it'll be a lot easier with a pencil. Alright, so that means my focus is at -1, 0, and I just figured that out from looking at where the focus is over here. It's at the coordinates -1, 0, and the directrix is always going to be the same distance from the vertex but on the opposite side, so it's going to be at +1 since the focus is at -1. So my directrix is going to be x equals 1. Okay, that's how we graph these, and it's actually, hopefully, you're seeing that this is really simple. Find your origin for your vertex. Find your C. Go 2 units up, 2 units down. Oops, that didn't go as well. And total that distance is 4, which is the same as this number over here. And then I'm going to connect those dots, and there's my parabola. That's how we do it. Alright, in your workbook you're also going to have a couple of problems where they're going to give you information, and then you're going to determine the equation. So if my vertex is 0, 0, and my focus is at 2, 0, what I like to do is just go ahead and draw myself a little graph so that I can see which direction is this going to open. So if the vertex is here at 0, 0, and my focus is up here at 2, 0, then that means my parabola has to look like this, because the focus has to be inside here of my parabola. So that tells me it opens up, which tells me that it's going to be positive, but it also tells me that it's going to be 4cy equals x squared, because parabolas that open up or down are always going to be x squared. So I know that my focus is 2. Well, that's really important because that actually tells me my c. Remember, c is going to be 2. So if I plug 2 in for c, my equation becomes 8y equals x squared, and I know that it's positive because this parabola opens up, and that's it. That's the equation. That's how simple that is. So when you're given the focus, you're automatically given the c, and all you have to do is plug it in. So let's look at another. I think I've got maybe one more example, maybe, nope. I don't have another example of that. So let me say it one more time. If you know your vertex and you're given your focus, then whatever that value is right there will be your c to plug into your equation. And if it's going to be upward facing, it will be x squared. If it's downward facing, it will be x squared. If it goes to the right, it would be y squared. And if it goes to the left, it would be y squared. Okay, in your workbook, you're only going to do 15 problems. It's on pages 136 and 137, numbers 1 through 15, all. And if you have any questions, see me in class.